Good morning, students.
Good morning, sir.
Okay, students. So, new chapter SHM. Okay. So, what SHM is actually? SHM means it's a repetitive motion, periodic motion. Okay. But slightly different from the normal periodic. Like normal periodic, we say circular motion, but this is not like circular motion. In this one, first let's write it as a periodic. It's a periodic motion. Second, it's to and fro, to and fro motion. And the most important thing about this is in this one, displacement, velocity, acceleration, all are written along with trigonometric functions. Okay, so if I say that displacement, so displacement we write as something like A sine omega. Okay, velocity we write as V naught cos omega. And acceleration we write as minus A naught sine omega t again. Okay, so displacement, velocity, and acceleration all are written along with trigonometric functions. That is the speciality of simple harmonic motion. Okay. Other than that is its acceleration is always directed towards mean position. Okay. Acceleration is always directed towards mean position. Okay. Fourth point, energy is conserved. Okay. Mechanical energy is conserved. Conserved in simple harmonic motion. Okay, so it's periodic. Periodic means is it is having certain time period, and after time period it is going to repeat its motion. To and fro, that means about a particular position, it is going to move to and fro, this side, that side, this side, that side. Acceleration is always directed towards mean position. That means there is something called mean position, and mean position is only the position about which it is going to oscillate. This is mean position here. This is extreme, we'll say, and this is extreme. Okay, mean position, extreme position, extreme position. So it's going to oscillate on either side of mean position. Okay, mechanical energy is conserved in SHM. That's okay, fine. From mean position to extreme position, this we call as amplitude, and this is also amplitude. Okay, time period we denote with capital T. Okay, so this is how it is. So first thing is these 4 points. Other than that, displacement is always associated with sine function, not sine function, trigonometric function you say, because when we are going to start the motion from extreme, we will be writing this as cos also. So definitely trigonometric function will be there with displacement as well as velocity as well as acceleration. Okay, now the question is how this came. So what we say is projection of a particle performing circular motion on diameter of a circle is SHM. Okay, what is the meaning? Its meaning is if there is a circle and a particle is doing circular motion, okay, and its projection if I am going to make on any of its diameter, y-axis or x-axis, anything. These two are diameters I have made. Okay, one is along x-axis, one is along y-axis. And if the one particle is moving in circular motion, let's say its particle's initial position is this, and it is going to reach over here after some time. So this is initial position, position A. Okay. So initial position, let's say initial angular position, let's say, is theta. Okay, and this is moving with angular velocity of omega. So at time t, this is initial, at t equal to 0. Okay, at time t is going to reach at point B. Okay, so join that one also again. Sorry, yeah, right. Okay, so from here to here, how much time it has got? T time. What is its angular speed? Omega. So how much angle it has moved? Omega t. Yes, omega t. Okay, now its projection. What about its projection? So projection must have started from here, because this projection along y-axis is here, and when it is at B, its projection is here. So the question is, from mean position, this is mean position, how much is its displacement? This displacement from mean position, what is its position? We'll say it's y. Okay, we'll say that is y. And what is y here? Okay, what is this? We can say this is exactly equal to this value here. Okay, if this is y, so is this. This is also y. So in this triangle, I can say y is equal to r sine omega t plus theta. Okay, y is equal to r. R is what? R is radius, and this angle is omega t plus theta. So this will become r sine omega t plus theta. Okay, so this is the displacement, and you can see that displacement is with sine function. What is theta here? Theta we call as initial phase. That means initial angular position of particle performing circular motion. But in SHM we call this as initial phase. Initial phase of the particle, this theta. Whereas in circular motion it is called initial angular position. Okay. And omega t plus theta total is called phase of the particle. Phase of particle. Okay. And this r value we are going to replace with a. So we'll write this as a sine omega t plus theta. What is a? A is amplitude, maximum displacement from mean position. That means this particle can move maximum to what? Here. And that's equal to radius only. So we are writing it as a sine omega t plus theta. So this is how displacement is written. Okay, y equal to a sine omega t plus theta, or you write omega t only. Consider theta initial phase is 0 for the time being. So this is displacement. Then velocity. Velocity will be what? Differentiation of this. So what's going to come? A omega cos omega t. So this a omega we can write as v naught. So this become v naught cos omega t. Okay, same way acceleration, one more time differentiation. D square y by dt square. Okay, so its differentiation will be what? Say minus omega square a sine omega t. Okay, so y is a sine omega t, velocity is a omega cos omega t, and acceleration is minus omega square a sine omega t. Okay, now velocities, these are all formulas. Okay, so velocity is one more formula we will be getting. What formula? Because v naught, v we are writing as v naught cos omega t. So we can convert this in terms of sine also. V equal to v naught cos omega t we can write as 1 minus sine square omega t. So from here we will get another formula. What is that? Say omega root over a square minus y square. This v naught is a omega. Okay. This v naught is a omega. So another formula that we will be getting is v equal to omega root over a square minus y square. Same way for acceleration also we will get one formula. What is that? Acceleration will be minus omega square y. Acceleration will be minus omega square a sine omega t. We can write as what? Y. So acceleration is minus omega square y, v equal to omega root over a square minus y square. And when you are talking about the displacement of the particle from mean position, we will be taking displacement formula as A sin omega t, velocity formula as A omega cos omega t, acceleration formula is minus omega square is sin omega t. Okay, let's do a few problems so that you can understand where we use them. Okay, before going for the graphs, let's do a few problems. Okay, see how these problems are. Question asks us how much time particle take to move from x equal to 0 to x equal to a by root 2. Its time period is t. Now, what is the formula? X equal to a sin omega t. There we got y equal to a sin omega t, no problem. Okay, we can write x equal to a sin omega t. Okay, right. So, how much time particle takes to move from x equal to 0? Now, x equal to 0 means what? Mean position. That's mean position. So, mean position to a by root 2 particle is moving. So, a by root 2 is what now? Because time we have to find. Okay, its time period is t, we have to find how much time particle takes. Okay, so a by root 2 means what? How to find? Nothing, it's a by root 2 means what? A by root 2, if we keep it over here, we will be getting omega t value. That's all. That will give us answer. Okay, see then, a by root 2 equal to a sin omega t is cancelled. This is 1 by root 2. 1 by root 2 means what? 45 degrees, right? So sin inverse 1 by root 2 equal to omega t. So this is 45. 45 means pi by 4. So pi by 4 equal to 2 pi by t into t. Pi cancelled. So t equal to t by 8. T equal to t by 8. Or directly a by root 2 means a sin theta is equal to a by root 2. This is 45 degree. Directly come over here. And you can take t by 8 seconds. Okay. Same way, see the second question now. Second question says what? Second question. Okay. Second question is this. What is that? X equal to 0 to x equal to root 3 a by 2. Now we know that 0 to a by root 2 means it was 45 degrees. Now here 0 to root 3 a by 2. Sine only we are talking. So this has to be 60 degrees. Okay. So if we know that theta is 60 degrees, directly we can write theta equal to omega t. So omega t equal to pi by 3. 2 pi by t into t equal to pi by 3. Pi gets cancelled. T equal to t by 6 seconds. Particle will move from x equal to 0 to x equal to root 3 a by 2 in t by 6 seconds. That's all, over. Then x equal to 0 to x equal to minus a by 2. Where is minus a by 2? Okay, so now we have to understand this. Minus a by 2 is where? Okay, so see. If this is how the SHM is happening, this is x equal to 0, this is x equal to a. So x equal to 0 you went like this, then came back to x equal to 0, now you are going this side, and this is minus a by 2. So it went like this, came back like this, and then like this. So how much angle it has to move? Okay, so this is what? This is sin theta's value is minus 1 by 2, because x is always what? A sin theta. So this is minus a by 2. Okay, let's keep it. So x equal to a sin omega t, right? This is minus a by 2. So a sin omega t. A gets cancelled. Sin inverse minus half equal to omega t. Okay, so this is what actually? How much angle it is? Can you find? Now see then. This is slightly tricky. Okay, so when you have moved from here to here, 0 to a, how much angle you have travelled? 90. From 0 to extreme, 90 degrees. Then from here again back to 0, how much you have travelled? 90. Now this is here. Now in this kind of a question, if suppose sine inverse minus half we know, then there is no problem. But sine inverse minus half also comes in second quadrant also and third quadrant also. So there is a problem. Okay. So what he will do, we will try to solve this one with the circle. Circle is going to help us. Shall we draw a circle over here? Okay, let's see. So it's here. Okay. And motion is along x-axis. And this is our mean position. And the particle which is doing circular motion, because we have to understand through circular motion only, the particle which is doing circular motion is here. And how it's doing circular motion? Like this. Okay, so first it has moved from 0 to A. 0 to A. When it is moving from 0 to A, that means your particle is moving from here to here. Okay, because projection of this particle on diameter we have to see. So if projection is moving from here to here, that means particle is moving like this to this. Okay, that is from 0 to A. Then from A to 0 again back. So A to 0 means like this it will come back. So our circular motion doing particle is also coming like this. Okay, then from here it comes here, minus A by 2. When it comes to minus A by 2, where is this particle? This particle is here. Who? Circular motion doing particle is here. Okay, now join this and make this. Okay, what is this given to us? This is given to you is minus A by 2. This one, this here. Okay, and what is the radius? A. Radius is A. So what is this angle? If suppose I say this is theta, this is sine theta equal to A by 2 by A. So that is 1 by 2. That means theta equal to 30 degrees. So this is 30. But how much this circular motion doing particle has moved? 90 plus 90 plus 30. 210 degrees. So this is 210 degrees. Sine inverse minus half. Okay. Now put it. So 210. So 210 into pi by 180, because we have to write in radians, equal to 2 pi by t into t. Pi and pi gets cancelled. Okay, this is 7 and this is 6. So our answer is 7t by 6 equal to t. No, 2 is also there. So 12. 7t by 12. Okay, so this is how we calculate how much time it takes to move from one position to other position. One position means is what is in terms of circular motion, because everything you can do only from circular motion. Sin theta, cos theta, everything is helping in that only. Okay, so if you can understand the circular motion over here, you can find the time for any position. Any position. Yes, sir? Any doubt?
No, sir.
Okay, good. Okay, so fine. This is how we can solve position and time problems. Okay. Then now we are going for velocity. Find time in which velocity changes from v naught to v naught by 2 when particle starts from mean position. So always remember, now if we talk about velocity, okay, velocity, just let's understand first. Okay, so this is mean position here, this is extreme, and this is also extreme. So where velocity is maximum? At mean position. At extreme position, velocity is 0, and here also 0. So velocity maximum is at mean position. Okay, question says you find time in which velocity changes from v naught. So v naught means it's starting from mean position, and then it becomes v naught by 2. So maybe somewhere here, because as it's moving, its velocity actually is decreasing. So this is v naught by 2. But what we have to find? Time. In how much time? So now I can understand time only if I get theta value. In how much theta this is decreased from v naught to v naught by 2. What I will do? Velocity is represented as in cos function. V we write as like this. Okay, put it here. This is V naught by 2. V naught cos omega t. Cos inverse 1 by 2. Cos inverse 1 by 2 means 60 degrees. 60 degree means pi by 3. Pi by 3 equal to omega t, or pi by 3 equal to 2 pi by t into t. Pi gets cancelled. So t equal to t by 6. Over. First question over. Second one says V naught to root 3 by 2 V naught. Okay, fine. So root 3 by 2 V naught. So root 3 by 2 V naught equal to V naught cos omega t. V naught cancelled. Sorry, V naught cancelled. Okay. So cos inverse root 3 by 2. Cos inverse root 3 by 2 is what? 30 degrees. Cos 30 is only root 3 by 2. So 30 degrees means pi by 6. Pi by 6 equal to 2 pi by t into t. So t equal to t by 12. Okay. Then what else we can say? Same way you can also say over here that okay, in this direction if its velocity is coming, and in this direction its velocity has become minus v naught by 2. That also we can. Okay. We can find out in how much time or how much angle is going to travel. Okay. So for v naught by 2, this side how much? 60 degree was there. So this also will be 60 degrees. For this v naught by 2, 60 degrees. So this also 60 degrees. So how it would have gone? 90, 90, 60. So 240 degrees. We have done same. 240 degree equal to omega t. 240 into pi by 180 equal to 2 pi by t into t. Pi cancelled. This is 4 and this is 3. So 4t by 6 is the time, or 2t by 3. Okay, because it's similar. Both sides is exactly similar. Here to here v naught by 2, so here to here v naught by 2. Okay, exactly similarly we can do. Here also you see the previous case also it was similar only. What it was? X naught to, okay, a by 2 we have not done. Okay, we have not done. That's how it was coming as 30 degree over here. If you would have done a naught by 2 also, no, here. This was also 30 degrees. So this also 30 degrees. We calculated here. It's exactly similar. Okay. Alright. Then what next is? Okay, next is for acceleration. Let's see that also. Time taken to change acceleration from minus a naught to 0. Okay. Minus a naught to 0 means what? Let's understand. Okay, this is mean position. Now at mean position, what is acceleration? Acceleration is 0 at mean position. Sine function, no? So it's 0, sine 0 is 0. So acceleration is 0 at mean position. Then where is minus a by a naught? Here, at extreme. Acceleration is in this direction. Here also acceleration will be a naught, but it will be plus. So here only it's minus. So what he says, time taken to change acceleration from minus a naught to 0. That means from here to here you want to come. So from extreme to mean position you want to come. So how much angle you will rotate? How much angle you will traverse in circular motion? 90 degrees. That's all. So first question's answer, pi by 2 equal to omega t. So pi by 2 equal to 2 pi by t into t. This is cancelled. So t equal to t by 4. This was very easy question. Okay. Next one. Minus a naught to minus root 3 by 2 a naught. Minus a naught is this. Minus root 3 by 2 a naught, maybe somewhere here it will be there. Okay, somewhere here. So what I have to do? I have to find what is this angle. Okay, acceleration is what? Acceleration actually is minus a naught sine omega t. So this is what? Minus root 3 by 2 a naught. Okay, minus root 3 by 2 a naught. Okay, fine. minus A naught sine omega t. Okay, fine, A naught cancelled, minus cancelled. Now sine inverse root 3 by 2. But in this one there is one problem. What problem is there? Because now minus root 3a by 2 A naught it is saying from this position. So it has already travelled 90. Now this is 90 plus something. Okay, this is 90 plus something. Understood that? So this is sine omega t we should write, or sine of 90 plus omega t we should write. That is only we have to see. Okay. Oh, wait a second. Okay, so that is what we have to take care. Otherwise, answer will come wrong. Answer will be wrong. Okay, because you already told 90. From there you are coming. So then, how much is this? How much is this time we have to calculate, not this time. Okay, see what I am trying to tell you. Now, what would have happened if suppose that particle when it was going from this to this here, okay, and the particle was going from here to here. Here also somewhere root 3 by 2 A naught must have come, because it's increasing up to A naught. Okay, there we would have written root 3 by 2 A naught equal to A naught sine omega t. Correct or not? We would have written that. Then we would have got the answer at that time. What is this? This will be 60 degrees. That's at 60. Okay, into whatever, 60 degree. Okay, this is omega t. This is 60 degrees, right? So if this is 60, obviously this also will be 60, the other side when it is coming. So how much it has traveled? I have to find this. So this would have come 30 degrees. What it will come? 30 degrees. So how much it has traveled? 90 plus 30, that is 120 degrees. So this answer is 120. That is what I am trying to tell you. Okay, that is sine 90 plus 30, that is cos 30. Cos 30 also root 3 by 2. Then only you will understand that. Then only you will be getting the answer. Okay, so in this case, what I will write? You go with sine only. You always find it from mean position. That is only better. Don't do it from this side. Okay, that will create problem. So do it from mean position always. So this is 60 degrees. So this is 30. So this is 90 plus 30. How much we have traveled? 120 degrees. So 120 into pi by 180 equal to omega t. This is 2, this is 3. So 2 pi by 3 is equal to 2 pi by t into t. Okay, 2 pi cancel. So t is coming as t by 3. Okay, remember always what I told you, always go from mean position. Whatever value it says, from first one from mean position you find out what angle. Okay, then you see that whether it's coming back or it's going directly. If it's going directly, then that value only will take. But if it's coming back, then 90 plus the other side will take. It will be easy for you and you will not get wrong answer also. Okay, otherwise you can get confused. Okay, so this is how we can do the questions based on displacement, velocity and acceleration. Okay, then okay, when displacement of particle from mean position is a by 2, what is velocity and acceleration? Displacement of particle from mean position is a by 2. What is velocity and acceleration? Now, if from mean position, its position is a by 2, what is its angular position? Everything is related to angular position only, remember. Okay, this is a, now he says particle is at a by 2. So what? A by 2 equal to a sin theta or a sin omega t. A sin theta is fine, or omega t you want to write. Okay, right. So this is cancelled. 1 by 2 sin inverse 1 by 2 means 30 degrees. So 30 degrees is equal to omega t. Now what the question is asking? velocity. Now we know what is velocity. Velocity is a omega cos omega t. Omega t value I have got 30. We'll put it here. A omega cos 30. Then acceleration. Acceleration is what? Minus omega square a sin omega t, and omega t value again you have minus omega square a sin 30. Okay, so angular position if you have, you can write displacement, velocity, acceleration, anything. Okay, this is how SHM is. Let's see then again what else is there. Okay, V max and A max, that also we can find, but let's discuss first what is V max and A max. So we are going back. Okay, going back. We are here. Okay, y equal to a sin omega t, v equal to a omega cos omega t, acceleration is minus omega square a sin omega t, velocity is one more formula, omega root over a square minus y square, and acceleration is minus omega square y. Okay, now we are talking about V max and acceleration maximum. Okay, so what is V maximum? V maximum is then when this cos omega t becomes 1. When this cos omega t becomes 1. So V maximum is actually a omega. Okay, so V maximum is actually equal to a omega. Same way, acceleration maximum. The acceleration maximum will be there when sin omega t is 1. That means acceleration maximum will be minus omega square a. Magnitude will be omega square a. Okay, acceleration maximum, its magnitude is omega square a. This is the maximum value. Where V will be maximum? This will be maximum at mean position. Where acceleration maximum? At extreme position. Okay, acceleration is maximum at extreme and velocity is maximum at mean. Okay, now let's go back to that question again. So where is that question? Here. So it says t equal to 4 seconds, amplitude is 8, find V max and A max. Very simple. Okay, V max is what? A omega. A given, omega also given. So A is 8 and omega is 2 pi by t and time period is given to us 4 seconds. So then 8 into 2 pi by 4. This is 2. So 4 pi. Say 4 pi meter per second. Maximum velocity. Then acceleration maximum. Acceleration's maximum value is omega square a. Omega value is what? 2 pi by 4. 2 pi by 4 means pi by 2. So pi by 2 square into 8. So pi square by 4 into 8. 2 pi square meter per second square. Then ratio of V max to A max. Now ratio is what? A omega by omega square a. A cancel, omega cancel. This is actually 1 by omega only. That means t by 2 pi. So 4 by 2 pi. That is 2 by pi. Okay. So this is V maximum and A maximum. Right? Okay. Then, okay. Let's go back. Now what we have? We have graphs. Graphs related to simple harmonic motion. So first graph that we want to make here is for displacement. Okay. First we will make for displacement. It's a sine curve. We know this is y and t. It's like this. Y equal to a sine omega t. Okay, sine omega t. Now, in this one, this time period here is what? T. This is t by 2. This is t by 4. And this is 3t by 4. Okay, the time in which circle is completed, in the same time one oscillation is also completed. Circle is what one? We said no. The SHM is basically the projection of the particle doing circular motion on its diameter. Okay, so the time in which particle is doing circular motion, in the same time its projection is completing one oscillation. So this is y equal to a sin omega t. Same way we can make for velocity also. Okay, but velocity is a cost function. Okay. So when we are talking about mean position, this represents mean position here. Velocity is maximum. Velocity is maximum here. So it will start like this, in this way. This is V max, A omega. Actually, this is V, Vt. This velocity is what? A omega. And this is amplitude A. Okay, everything same. But this is Vt graph. Same way, acceleration time graph. Acceleration time graph is also sine curve. This is cos curve. V equal to A omega cos omega t. Then acceleration. Acceleration curve is like this. Why like this? Because this is negative. Minus omega square is sine omega t. This is acceleration time curve. What is the phase difference between velocity and displacement curve? 90 degrees. Remember that, very important. Phase difference. Because one is cos function and other one is sine function. Then, what is phase difference between this and this? Again 90. Here is also 90. Then displacement and acceleration 180 degrees. Okay, 90, 90, 180. Okay, now these are related to time t, we have made the graphs. Then any other graphs are there? Yes, other graphs are also there. Okay, velocity and displacement graph also we can make. So velocity and displacement graph is how it is. Velocity and displacement. Okay, this is velocity, let's say, and this is displacement. Displacement y or x, anything. Now, what is the relation first? The relation is v equal to omega root over a square minus y square. Isn't it? This was the relation. Let's see what we have made. Here it is. Velocity v equal to omega root over a square minus y square. Okay, fine. Now we have to make the graph for that between v and y. So what to do? Simple, that is, put v by omega here. This is a square minus y square, square root, square it both sides. V square by omega square equal to a square minus y square. Okay. Then what we can do? Then y square equal to a square plus v square by omega square. Okay. Further, y square equal to a square omega square plus v square by omega square by omega square. So this is basically ellipse. Okay, this is ellipse equation. Right, what we can do in this one also, can we take anything common over here? V square by omega square, fine. That's all, nothing else. Okay, so in this one, what type of equation is this? This is actually equation something like this: x square by a square plus y square by b square equal to 1. This is ellipse equation. We can convert this in the same form. Okay, we can convert this in same form. How? Just see, we can do that or not. Correct only I have done at the moment, na? No, something wrong is there. There is minus over here. Wait. Okay, we'll do like this. V square by omega squared plus y square equal to a square. Then V square by a square omega square plus y square by a square equal to 1. This is better. Okay. So one is along y-axis, one is along x-axis. So v and y. This is along y, this is along x. So it's very similar to this. X square by a square plus y square by b square equal to 1. So how is the graph? Graph is ellipse. Remember that. Graph is ellipse. Something like this. Okay. This is the graph. What are the maximum values? We can write V's maximum value is a omega. This is a omega. And maximum value of y is a. This is a. Okay. So remember, it's ellipse between velocity and position, displacement. Then which graph is left? Acceleration. So acceleration and y. Okay. This is here and this is here. Okay. Now we can say this is a and this is y. Now what's the relation? Relation is a equal to minus omega square y. Acceleration is minus omega square y. So if you are going y positive, if y is positive, acceleration will be negative. Okay. If you are going in this direction, acceleration will be negative, like this. And if you are going this direction, negative y, acceleration will be positive. Okay, and there is a direct proportionality because omega is constant. Okay, so how that will be? It will be like this. It will be passing through origin. Okay, something like this. This is the graph. Acceleration equal to minus omega square y. Right? Acceleration and displacement graph. So these are the graphs which are related with SHM. Okay. Then where we'll go? We'll go to kinetic and potential energy. Potential and kinetic energy. Here we are. Okay. So kinetic energy. Now kinetic energy's form is always same. It's always written as half mv square. Okay. And what is the velocity of a particle doing SHM? A omega cos omega t. Simple. Square of this. Okay. So half m a square omega square cos square omega t. Right. And another form is also there. Or. Here we'll write or. Half m omega into root over a square minus y square. This also is velocity formula. Okay. So what's going to come? Half m omega square a square minus y square. So this is kinetic energy. Okay. Half m omega square to a square minus y square. Correct. Then what about potential energy? Now potential energy we would like to find with the help of spring. Okay. What used to be spring energy? You say half kx square. So here I am saying half ky square. What is y? A sin omega t. So half k a sin omega t whole square. Now question is, what is this k? This k value we have to find now. Okay. So this k value we'll find. So for k value only I am going to spring mass system so that we can find k value. Okay. Let's see here. Not there. Okay, fine. Okay, the spring mass system. Spring mass system. Right. So now what happens in spring mass system? This is spring, and here is one mass, this spring constant. Now suppose that this is in unstretched position, that is mean position here. We are going to stretch the spring. We are bringing this mass here. Okay, this is x. Right, this is x. Now, when we are going to stretch it by x at this position, what is its potential energy? We will say half kx square. Okay, now when we are going to release it, when we release it here, and when it is going to reach to mean position, what type of energy it will have? Kinetic. Which kinetic? Maximum kinetic. That means this kinetic energy maximum will be equal to potential energy maximum because energy is conserved. Okay, so at mean position, entire potential energy at extreme will be converted. Okay, so kinetic energy is equal to, or kinetic energy maximum, I'll write. Kinetic energy maximum is equal to potential energy maximum. What is this? This is half kx square. And what is this kinetic energy? Half mv square. But v is a square omega square. Okay, and this x also I should be able to write a square only because that's the amplitude. So half k a square. So a square cancelled. Now you can see k is what? K value is m omega square. So if we are taking potential energy from spring mass system, then we should know spring constant is equal to what? Spring constant is equal to m omega square. Remember that. The spring constant is equal to m omega square. Okay. So let's go back. Let's go back here. Okay. So we have written half ky square. Now what is k? M omega square. So half m omega square a square sine square omega t. Okay, this is potential energy. Alright, so half m omega square y square you write, or half m omega square a square sine square omega t you write. Both are same. Okay, half m omega square y square. And this is half m omega square a square minus y square, or half m a square omega square cos square omega t. This is kinetic energy, this is potential energy. And as I told you, total energy is conserved. Total energy is conserved. That means sum of kinetic energy and potential energy is constant in SHM. That is not going to change. Okay, right? Just take a 1 minute break. Okay, I'll take water and come. Yes, students. So now let's see what type of questions are there on kinetic and potential energy. Right. So what this is? Time period of a particle doing SHM 2 seconds. At what time kinetic energy becomes 75% of total energy? Okay. Kinetic energy is 75% of total energy. How to solve this? So this is how our particle is doing SHM. This is mean position. And mean position what we have? Total energy is kinetic energy. Total is kinetic. As you are moving towards extreme, kinetic energy starts converting into potential energy. Okay. So here he says kinetic energy is 75% of potential energy, 75% of total energy. That means here it is 100. Okay, kinetic energy at mean position is 100% of total energy. Potential energy at mean position 0. Okay, now question is, when kinetic energy is 75% of total energy, then where is 25%? Potential energy. Somewhere here maybe. Okay, so kinetic is 75% of total. So then PE is 25% of total energy. PE, potential energy, is 25%. What question is asking? At what time? Okay, fine. So potential energy is 25% of total energy. Okay, what is total energy? Total energy is half m omega square a square. From where this formula came, I didn't discuss this with you. Okay, let's see. This is maximum potential energy. Sorry, this is potential energy. When it will be maximum? When Y will be maximum. Okay, see here also. When kinetic energy is maximum? At mean position. At mean position, what is Y value? 0. Okay, kinetic energy maximum at mean position where Y is 0. That is, kinetic energy maximum is half m omega square a square. Right. Same way, potential energy maximum. Potential energy maximum is at extreme. At extreme. Okay. At extreme position, what is Y value? A. So potential energy maximum is what? Half m omega square a square. Half m omega square a square. So this is potential energy maximum, this is kinetic energy maximum. Right? So potential energy maximum or kinetic energy maximum both have same values, obviously. Has to be same value. Okay? Right. So when kinetic energy is maximum, then potential energy is what? 0. When potential energy is maximum, what is kinetic energy? 0. Clear? Let's come back. So what we say? Kinetic energy at mean position is 100% of total energy, potential energy is 0. At this position, kinetic energy is 75% of total. Here 100% of total, here 75%. So where is remaining? It is converted into potential energy. So now my question I have changed. I am not going to talk about kinetic energy. I am going to talk about potential energy. In how much time my potential energy converted from 0 to 25% of total. Okay, I changed my question. So if suppose here is asked from me at what time potential energy is 25% of total energy, both are same answers. Okay, total energy is this. Now potential energy is 25% of total energy. So potential energy formula, half m omega square y square. Half m omega square y square equal to 25%. Okay, so 25 by 100 into half m omega square a square. So m omega square you can cancel. Then half also you can cancel if you want. So y square equal to 1 by 4 a square. That means y equal to a by 2. Okay, so from mean position you have just moved a by 2, and a by 2 is what angle we know, we already have done. A by 2 means 30 degrees. Okay, y equal to a sin omega t, just recollect, a by 2 equal to a sin omega t. Okay, so 1 by 2 equal to sin omega t. So that's 30 degrees. 30 degree means pi by 6. Pi by 6 equal to 2 pi by t into t. What else? 2 pi. 2 pi by t. So pi cancelled. T equal to t by 12. Now what is t? T is given 2 seconds. So 2 by 12, that is 1 by 6 seconds. Simple. So from kinetic energy and potential energy also same kind of a question is asked from you, where they can ask you time. Okay, but then you can ask me that from here also we could have done the question. We could have done. Here also we could have written that it is 75% of kinetic energy. Okay, 75% of maximum, and then we would have written here. We can do that. Why not? We can. Okay, so this we did. Now next, what's next? Mass is 0.1 kg, total energy is 10, potential energy and kinetic energy are equal at x equal to 1 centimeter. Now we already know where potential and kinetic energy are maximum. We know that, right? No, we'll do that question first and then we'll come back. Okay, this is all right. We'll do question here. Okay, what is the question? Find where kinetic energy is equal to potential energy in SHM of amplitude A and time period T. Okay, so kinetic energy and potential energy are equal, we are saying. General form, whatever general form we know, that we have to equate, because we are not saying here anything is maximum. Okay, so potential energy equal to kinetic energy. So general form is what? Half m omega square y square, and this is half m omega square root over, not root here, square, that is half m omega square a square minus y square. Okay, so half m omega square you can see is cancelled. So y square equal to a square minus y square, that is 2y square equal to a square, that is y equal to plus minus a by root 2. Okay, at a by root 2, potential and kinetic energy will be equal. What is a by root 2? Displacement. And a by root 2 displacement means what? 45 degree angle, right? Theta is 45 degrees. Angular position will be 45. Correct? Clear? So what he wanted? Find where. So we found it. Okay. Now let's go back. What was the question? Here it is. No, not this one, next one. Yes. So potential energy equal to kinetic energy at x equal to 1. Oh, this is x equal to 1. Okay, but we said that it is has to be a by root 2, right? So a by root 2 is given 1 to you. What is a then? Root 2. He is asking a also. Okay, so we did it from that question itself. A equal to root 2 centimeters. Okay, fine. Now what else we have to do? We have to find time period. We have to find time period. Okay, but here time total energy is also given to us. We didn't use it. We'll use it now. Total energy is 10. Total energy means half m omega square a square equal to 10. Okay, and amplitude we already have. So 1 by 2, 0.1 into omega we are finding, right? Yeah, time period we are finding. So omega we are finding. Amplitude is root 2, so we'll write 2 here, equal to 10. 10 is what? Joule. We'll make it in CGS, okay? Can we do in CGS? No, this is also in 0.1 kg. So this only we have to convert it in meters then. Okay, fine. So 2, okay. Everything is else in SI only, right? Yeah. So root 2 centimeter, that means root 2 into 10 to the power minus 2. Square it, it will become 2 into 10 to the power minus 4. Very big answer will come. Okay, fine. This 2 and 2 gets cancelled here. 0.1 into 10 to the power minus 4. That means 10 to the power minus 5. Omega square is equal to 10 by 10 to the power minus 5. That is 10 to the power 6. So omega is going to come 1000 radian per second. And what he wants? Time period. So omega is 2 pi by t. So 2 pi by t equal to 1000. So t value is 2 pi by 1000 or pi by 500 seconds. Okay, that's pi by 500 seconds. Right? Clear? So this is how kinetic energy, potential energy questions we are able to solve. Let's see next. Find ratio of kinetic energy and potential energy at T equal to T by 12. Now this is with time. Okay, see then what it is. T by 12 is what? Let's see. Theta equal to omega t. So this is 2 pi by t into t by 12. This is cancelled. This is 6. So pi by 6, that means 30 degrees. 30 degrees. Okay, at 30 degrees, what is the position? So y equal to a sine 30. That means this is a by 2. Okay. So kinetic energy. Sorry, we'll not go for kinetic energy first. We'll go for potential energy. So potential energy half m omega square y square. So it is half m omega square into a square by 4. This potential energy. Okay, then kinetic energy half m omega square into a square minus y square. Okay, this is half m omega square a square minus a square by 4. So this will come 3a square by 4. So 3 by 8 m omega square a square. Now the ratio is asking kinetic energy by potential energy. So this by this. So you can see that denominator is 8 gets cancelled, m omega square a square gets cancelled. What is going to come? 3 by 1 or 3. Okay. So kinetic energy to potential energy 3 is to 1. Otherwise, question also will be asked, where exactly kinetic energy will be 3 times of potential energy. Okay, so these are the questions which will be asked on position, velocity, acceleration, kinetic energy, potential energy. Okay. Now, anything other than this is also there in potential energy and kinetic energy? Yes. In SHM, potential energy and kinetic energies are also oscillating. They are also oscillating, but they are oscillating between maximum value and 0. They are not going to negative value. Like the particle is going plus A also and minus A also. Okay. So kinetic energy and potential energy is not going from positive to negative. Positive to 0, again positive, again 0. Okay. So if we see the oscillation of kinetic energy or potential energy. So suppose this is kinetic energy here. Okay, and this is with what shall we do? Y. With Y we'll say. Okay. With time also we can make, but at the moment I am making with Y. This is mean position. So in mean position, what happens to kinetic energy? It's maximum. Okay, so you'll start with the maximum value from here. Then what happens? Then it reaches to extreme. Okay, so this is how it is. When it's reached to extreme, extreme means is what? Equal to amplitude. Equal to amplitude. Okay. Then what? Then again it should go maximum. But if I'm going to keep here y, I won't be able to make it. Then let's make it t only. Okay, because t only can increase. Y value means is a this side, then it has to come back to 0, then again it has to go to minus a. Okay, so it will not be possible. That's why y I removed. Okay, so kinetic energy became 0 at y equal to a. Then it has to go back. Go back means again potential this kinetic energy is going to increase because it will again reach to mean position. Okay, how it is? Let me just show you. Right. So this is mean position here. This is extreme. So here velocity was maximum like this, maximum velocity. Here velocity became 0. Now again it's coming back like this. Here again speed is maximum. But in opposite direction though. But kinetic energy is always positive. Okay. So maximum kinetic energy again 0. Okay, and again max. So in one time period, we are starting with the max, 0, max, 0, max. Okay, so 1, 2, 3. Okay, and 2 times 0. In one time period. Okay, this is what t by 4. This is t by 4. Okay, this is t by 2. This is 3t by 4. And this is t. In one time period, our kinetic energy is becoming maximum 2 times and 0 also 2 times. This value we can't take, it's t equal to 0. From here only we are starting. Okay, so between 0 and t, how many times you are becoming maximum? Twice. And 0 also twice. Okay, so its frequency is what? Its frequency is 2. Frequency of particle doing SHM is 1. It is completing one oscillation. It is reaching back to the same position. Okay, it was here, then it went like this and it reached. This is one oscillation. Okay, it reached back to the same position. We are calling it one oscillation. But in that one oscillation, kinetic energy is oscillating twice. It reached maximum twice, it reached 0 twice. Okay, starting from here at the same position, reached over here also. Then again it reached to the same position. So 2 times it reached, no. Whereas this particle is reaching at the same position only once. This is not the same position. This is when face is in this direction. Then it is turning back. So this is 1. Whereas kinetic energy is double. So frequency of kinetic energy is 2 times frequency of oscillation of particle. Oscillation of particle. Now what about potential energy? Potential energy also. Potential energy also. This is potential energy. Okay, now potential energy, this is mean position, then potential energy here will be 0. Okay, but here it will be maximum. So it will be like this. Sorry, made a mistake. Because potential energy also will never be negative here. Okay. Like this. Okay, 2 times max, 2 times 0. Okay, so frequency of potential energy is equal to frequency of kinetic energy. Remember that the frequency is double the frequency of particle doing oscillation. Right? kinetic energy, potential energy, velocity, displacement, acceleration, time period questions we saw. Now, what else? Now we are going to see how to find a time period of the system. Okay. These are the other type of questions these are asked. Time period of system. The two systems are there. One is spring mass, other one is simple pendulum. Okay. Spring mass and simple pendulum. The spring mass we'll see first. Okay, there is a method through which we used to find time period. The method says first find equilibrium position of the system. Okay, first get the equilibrium position. But there is a long method actually, we will not use it. But I am just writing. First find equilibrium position, then disturb it slightly, disturb mass slightly from equilibrium position. From equilibrium position. Okay, then write restoration force which is going to take it back to mean position. Write restoration force. Then find acceleration, restoring acceleration, and then equate it minus omega square into displacement. What is acceleration's actual value? Minus omega square y. Minus omega square displacement. Get the value of omega from here, find omega, and that's it. Omega we found means frequency also is there and time period is also there. So this is normally the method. But what are we going to do? If we take a simplest of spring mass system, simplest, okay, alright, simplest of spring mass system like this. This here. Now this is already in equilibrium position. Okay, there is definitely some extension in that because you have to support mg. Mg is acting down, so definitely there is spring force upwards. We can say kx equal to mg. So, but I am not going into that. I am going to tell you the shortcut method. What shortcut method is? Now this is already equilibrium position or mean position. I am not finding it. It is there, I am assuming. Now I am going to displace it. Now I am going to displace it with x. Okay. Now I am going to displace it with x. Then, now once you displace it with x, what you are going to do? You are going to leave it. Then only it will go up, right? So when you are going to leave it, just write which force, which is variable force among mg and spring force, which is variable? Spring. So just write the variable force. Forget about mg. Just leave that. Okay. Write variable force. So I am just writing that. Okay, in this direction kx is acting. That is only the variable force, which is going to take it back to mean position. Just write variable force, nothing else. So variable force I am writing. I am writing it as restoration force only. So minus kx I am writing. That's it. Then acceleration minus k by m into x. Then what you will do? Right, minus omega square into displacement. How much displacement you gave? X minus k by m into x. That's it. This is cancelled. This is cancelled. Omega is root k by m. So time period is 2 pi root over m by k. The time period is here. Okay, so you don't have to go for equilibrium position and you can do it directly. By doing it, what we are doing, we are saving at least 2 to 3 lines. 2 to 3 lines saving means is at least we saved some seconds. Okay, few seconds we are able to save. Let's see, can we apply this at some other places also. Okay. First thing is any spring mass system, its time period formula is 2 pi root over m by k. Remember that. Okay. Now, if spring is like this, then like this, its time period we have to find same time period, no change. Same. Okay. If we change it into this one, still it's same. Okay, same time period, or it's like this. Time period is still same. We will solve it in the same way. No change. All this is having same time period. Okay. So let's change it then, some other system. Okay. So what I am going to do is, I am going to take it like this. It's like this. This is massless pulley. This is K. Now it's time period we have to find. Okay. Now we know that in this position which is shown to us, definitely it's an equilibrium position. Okay, we know that. And what I have to do in this one, I am not going to find equilibrium position. I am just going to see that which force is variable, and that variable force which is working on this and taking it back to initial position. Okay, so what we are doing now, suppose that I brought it down by x. This block I am bringing down by x. Now the question arises over here, how much is the displacement of this pulley? Because displacement of the pulley is equal to the stretch in the spring. Okay, so how much pulley came down? We have to understand. This kind of a system is there. Okay, and this here, this side. Now suppose that this pulley I am going to bring down by y. No. We are going to bring down by y. Suppose y it came down. So that means pulley now is here. You brought it down by y. Now pulley is new position. Now question is, where this y, length of string, has gone? Because this pulley has come down. So this y means it will be coming to this, it will go down. What about this y then? Where is this y going? That also will come down here. Okay, listen again. If this pulley is going to come down by y, this side of string becomes free, this much string, and this string is also becoming free. Where will that go? It will come to this, right? So if pulley is coming down by y, this block will go down by 2y. Getting it? If this pulley comes down by y, this y length is going to be released, this y is also going to be released. Where will it go? To this block. So if I say here, I am bringing it down by x, then how much down this pulley has come down? X by 2. Check there. 2y is x, you are saying, no. So y is what? Okay, so pulley came down by y, which is x by 2. Fine, no issues. So if this is x by 2, then how much is spring force? Then spring force is kx by 2. Because stretch in spring is x by 2, so spring force is kx by 2. Absolutely fine. No problem at all. But what is restoration force on this? Spring force is not acting on this one. Who's acting? Tension. Tension is acting. This tension is variable here. Yes, tension is variable. Why? Because spring force is variable. So on this pulley, here is kx by 2 acting. Okay, here is T acting. Here also T is acting. This is massless pulley. Okay, so if I am going to write the equations here, I will say kx by 2 minus 2t equal to mass of pulley, which is 0, into acceleration. So T is what? 2t equal to kx by 2, that is T equal to kx by 4. So restoration force is kx by 4. That is what I wanted. That's it. Okay. So restoration force is minus kx by 4. Why minus? Restoration, opposite. Opposite to the displacement. You brought it down, it is taking it up. Then acceleration minus k by m, x by 4. Then write this as minus omega square x because you displaced it by x. So minus k by m, x by 4. X cancel, minus cancel, omega is equal to k by 4m. That's it. Done. I saved at least 4 to 5 lines in this one by not finding mean position. Without it I did, because I was searching variable force. From whatever is given, from that I calculated variable force and I solved. One more question you see. These are the questions on tougher sides actually. Don't expect these kinds of questions are coming. I am just telling you so that you can get the confidence. Okay. Alright. Then one more. Pulley. Okay. Then we'll fix it over here. Straight line I want. Okay, fine. We'll take it from this. Okay. Right. Okay, and then with this one mass is connected. It's here. Okay, and here I'll keep one spring. Like this. Okay, scale. Now it's time period you have to find. We can put it down like this, stretch it down. Then you are going to relieve. So it's going to oscillate. This is not going to do the rotatory motion. It's going to move up and down only. Okay. What to do? Same method. Variable force we have to find. Now we know that this, if we are going to bring down by x, then on this one tension only will be acting. Tension only can take it upwards. Here also tension. But here, because spring force is there, so you have stretch spring force. So maybe stretch in this one is y, let's say. So here will be ky acting, here will be ky acting. Now how much is y? We'll find it. Okay. But for pulley, I can say this 2 ky minus t equal to 0. That means t equal to 2 ky. Remember. Now only y I have to find, and that's all. Question is over. Okay. So now, when you are bringing this down by x, pulley entirely has to come down. Yeah, yes or no? Pulley entirely has to come down. Pulley has to come down here by x. By x. Okay. Okay. So this pulley came down by x because you pulled that block down by x. So if pulley came down by x, now what is to be done? You have to increase this length by x here and this length by x also. Because pulley came down, this string need to increase by x and this string also need to be increased by x. Now how it will increase? Who is going to give? Spring. Because it's not having extra length, it is tight at the moment. Now when you are bringing it down, from where this is coming? Spring, because spring only can stretch. So how much will be stretch in the spring? X plus x, 2x. So y value is 2x. So what is tension? 2k into 2x. This is only restoration force. Yes. So we can write it minus. Okay. This is restoration. So acceleration is what? Minus 4k by m into x. Then this is minus omega square x because you gave the displacement x only. So minus omega square x equal to minus 4k by m into x. That's it, over. Omega is root 4k by m. It's that simple. So if you are going with the variable force, you can solve it very easily. Any type of spring mass system. Okay. Let's move series and parallel connection of spring. Okay. The series connection of spring, what happens in that? Series connection. Okay. Now if you remember that when I was teaching you about elasticity, there I showed you the relation between K and Young's modulus. Remember that. Okay. That is also important. K equal to YA by L it was. Okay. So sometimes the question is asked that if there is a spring of length L, this is a spring of length L, spring constant is K. If it is cut into two halves, then what is the time? What is the spring constant? Then spring constant is what? Okay. So if this is cut into two halves, now each one is L by 2 length. So what is K? Y A by L by 2. What else? Because you didn't change Y, you didn't change area, only length here changed. So it became 2YA by L. That means it is 2K. Because K is this. Okay. If you are going to make it 1/3, then spring constant is 3 times. 1/4, then spring constant 4 times. Okay. So K is inversely proportional to length. Okay. Right. Series combination. The series combination, something like this. This is one spring and this is another spring. This is K1, this is K2. And we are fixing it over here. And let's assume that you are keeping one mass. Okay. So now what is its time period now? The time period's formula is 2 pi root over m by k. But what is k here? Because there are two springs. You have to find k effective. What's k effective now? That is only our question. Okay. So how to find? Find what we did is I'm going to stretch it by x. So when you stretch it by x, the stretch will be in this x or this x, or combined it will be x. Answer is combined it will be x. So in this one, let's assume that extension is x2, in this one x1. So I can write x1 plus x2 equal to x. There is no doubt about that. Okay. Now what? Now in this one, now when you are going to leave it after stretching it, what will happen is spring force will bring it back. So in this one, what will be spring force acting? How much spring force is going to act? Let's assume F. So this one, this spring is going to apply the force only on this mass, on this side, or on this side also it applies. Both sides it applies. Both sides. Reason is because you are, if suppose that I am here like this. So this side you applied the force and stretched it, and this side also it gets stretched because this is tied here. Okay, so if you want to come back, it will apply the force in both ways. Okay, so here it is applying, here also it will apply the same force. Same force. Then what will happen? Now this is spring you are stretching, so this will apply the force. Same force or different force? It will be same force only. This is also same, here is also same. Why same? Because spring we are taking massless. Okay, springs are massless. Springs are massless. So what? Then if I say that this is actually F1 and this is F1 and this is F2 and this is F2, then I'll write F1 minus F2 equal to mass into acceleration now. Mass is not there. So what will happen? Both are same. Okay. So F1 and F2, everything is same. So that means in series connection throughout, same force is getting transferred. Same force is getting transferred from one end to the other end. Even though there is a series combination, different springs are there, but the force is same from here to here. Okay. So what you'll do? This X1 I'll be writing is what? F by K1. This is F. F1 equal to F2 equal to F, right? And this X2 I'll be writing as F by K2. And then this X, F by K effective. That's all. What we are getting? 1 by K effective equal to 1 by K1 plus 1 by K2. So K effective value K1, K2 by K1 plus K2. So time period, what time period? 2 pi root over m by K effective. That's it. Because spring mass system means that is only the format. M by K effective. Parallel connection. In parallel connection, we'll fix it. Okay, two springs, one, another one, and here we are keeping the mass, and this is the table. Okay, so this is M, this is K1, this is K2. Now I am going to stretch it by X. What will happen? This will also stretch by X, this will also stretch by X. Both will stretch by same amount X. So what will happen? On this one also one force will be acting, which is K1X. On this one also force will be acting, which is K2X. Okay, so net force will be what? So F net will be K1X plus K2X. So this I will say K effective into X. Okay, X cancel, K effective value is K1 plus K2 in parallel. So again its time period also 2 pi root over m by K effective. So series and parallel connection is like this. We can solve in this very easily. Okay. Then this was about spring mass system. Now what is there? Pendulum is there. You will see pendulum also. Pendulum. Okay. A pendulum's time period also we know. We know that it's 2 pi root over L by G. Okay. 2 pi root over L by G is the time period. How we found? Same method. Same method means the original method, not this restoration force method. Okay. Restoration force method, variable force method, we are going to apply in spring mass alone. In this one, normal method. And in this one, normally, the question will not be related to what is the time period. Okay. So 2 pi root over L by G is the time period in this one. Okay. Then what type of question will be asked? They'll be asking you, like, if suppose that this is kept inside elevator. If there is an elevator which is moving up or down. Okay, this is an elevator which is going up, and here is the pendulum. Then what will be its time period? So we will say that in this one, its time period is going to be 2 pi root over L by G plus A. Why G plus A? Because this is moving upwards, so on this one pseudo force will be acting. So net downward force will become mg plus ma. Earlier case it was mg alone, now it is mg plus ma. So because of that, our time period is 2 pi root over L by G plus A. Okay, then now if this same system comes down, then what will happen? G minus A. Okay, same thing if we are going to bring down. This is coming down. Okay, this is the pendulum. So mg is acting down, then pseudo force is acting up, and here is tension. Actually, tension value only you are finding in this. Okay, so what is tension value? mg minus ma. So T equal to 2 pi root over L by g minus a. Okay, now one more case is there in which the same thing is going horizontally. Then what you'll do? Okay, this is moving horizontally like this. Then what will happen? So actually pendulum's equilibrium position is not this then. Here equilibrium position is here only, here equilibrium position is here only. But in this case equilibrium position is not here, equilibrium position is here. Because pseudo force is acting like this and mg is acting like this. And we all know that what is this angle? Tan inverse A by G. Okay, but what we have to do? We have to find tension value. As I told you, here tension value is mg plus ma, here tension value mg minus ma. So that only you are writing, the acceleration part. Okay, so here also the same. What is tension value? It's here, m root over a square plus g square. So what will be time period? Time period will be writing 2 pi root over L by root over g plus a square. This will be the time period. Okay. Right. Now, one question we'll make. Okay. Well, it's like this. And this is theta. And suppose that there is a box here. Box is here. Okay. So this is the box. And in this box, we have one pendulum inside. Mass is m. Now its time period is asked from us. Okay, and it's released. Box is released. So its time period. Now we know that if suppose it's released, this box will go down, it will slip down. It's a frictionless surface. So this acceleration will be g sine theta, we know. Okay, so if acceleration is g sine theta, then pseudo force will be there on that block. Which one? This one. How much? Mg sine theta like this. This is pseudo force. And its own weight is acting down like this mg. So its components will be there. Yes, in this direction component is there mg sine theta. And this direction component is mg cos theta. Now question is what is its time period? This simple pendulums. Okay, so what you can see is in this direction, this is its weights component, mg sine theta is acting, and this direction is pseudo force acting. Both are equal in magnitude. So in this direction, total force 0. Mg cos theta is acting like this, and obviously tension will be here. The tension value is what? Mg cos theta. So what will be time period? Time period is 2 pi root over L by g cos theta. I told you tension. Okay, tension only we have to find in simple pendulum. Okay, one more question we'll do. Last question on the SHM now. Okay, now this question is related to gravitation. Okay, this is our Earth. So this is radius. We will say, wait. We'll make a tunnel in this. Okay. There's a tunnel like this. Okay. So there is a tunnel. In this tunnel, we have kept one box here at the center. We can make this tunnel a little more smaller actually. Okay, but fine. We have kept it at center. Radius is r obviously. Okay, and mass of the earth is m. So this block is at equilibrium position here, because we know that at the center of the earth there is no gravitation field, so no gravitation field means no force. Okay, now we are displacing it by x. We brought it here. This is x. Now question is, this will go back because of gravitation force. From the center there will be force acting on it. It will go back and then it's going to do SHM. So what is the time period of that? What we have to do? Our method says find restoration force directly. So what is restoration force here? Restoration force is due to the gravitation force of earth. Okay. So one thing we can do, we will find the gravitation field value here and multiply with m, that is the force. Or you directly calculate, it's our wish. So I am going along with the gravitation field directly, or acceleration due to gravity here. Both are same. Okay. So for that what is required? You can see that. Can you use Gauss law? Yes, you can use Gauss law, but Gauss law is also will be slightly longer. I want to go with the smaller method. So I am seeing that this is the surface, and from surface how much inside you went? R minus x. So if you are below the surface of the earth, what is the value of acceleration due to gravity? G dash equal to g into 1 minus d by r. And what is d here? R minus x. That's it. Okay. So mass into acceleration due to gravity. What is it? G into 1 minus r minus x by r. That's it. Over. Okay. Then what? Just solve it. Mg r minus r plus x by r. Am I right? I think so. This is cancelled. So mg x by r. This is the restoration force. But restoration force is taken negative because it's always opposite to the displacement. You have given displacement like this, restoration force is back. So you can put it negative here. Now this is what? Force. Then acceleration minus mg x by r by m. M gets cancelled. Now we can write this as minus omega square x minus g x by r. This is cancelled. X is cancelled. So omega is g by r square root t equal to 2 pi root over r by g. See, this value I directly took from there. So even Gauss law I did not apply. Do you remember the Gauss law? Gauss law was what? E dot ds equal to minus 4 pi g mass inside. Am I writing correct? No? Yeah. Minus 4 pi g mass inside. So that also you can use. Shall we use one more time? Recollect it? Okay, see. So E dot ds. So E into ds means this. So what shall I take its radius? X. 4 pi x square minus 4 pi g. Mass inside. Mass inside this. That will be density into volume of this. 4 by 3 pi x cube. Density means what? Now 4 pi I'll cancel first. So E into x square minus g. Now density is what? Mass by volume. So mass by 4 by 3 pi capital R cube into 4 by 3 pi x cube. 4 by 3 pi cancelled. With x square, this x cube, x is cancelled. Okay. What we got? Electric field, not electric field. Gravitation field is equal to minus gm by r cube, minus gm by r cube into x. Okay. Now in this one, we know that gm by r square is small g. So minus gm by r square into x by r. So this is g minus g x by r. Let's check. Is this the acceleration we have written? Yes, minus gx by r, minus gx by r. So see that even when you are applying Gauss law, this much you have to write. And here directly we got restoration because we were remembering that if you are coming to certain depth from the surface, how much is the value of acceleration due to gravity, acceleration directly. So here I have written force. Directly I would have written here acceleration, right? M I would not have written. So directly we would have got the answer. Fine. So this way it depends, like because gravitation we have done, so we can use all this. Okay students, so this is SHM. We finished SHM now. Go revise it and practice as much as possible. I have to put the practice test of the previous one also, that is properties of matter also I have to keep, and SHM also I'll try. Okay. Okay students, then take the scan of whatever we have done today. Okay. So scan it. Done? Okay. Okay students, then see you tomorrow with waves. Okay. Bye bye.
Thank you, sir.